In the previous video, we talked about a Cournot duopoly, which is a oligopoly with two firms producing a similar product, and they choose their quantities based on MC equals MR simultaneously and independently. So we showed what would happen if they chose simultaneously and independently. Then we showed a possibility for the two firms to collude and act like a monopolist to maximize their profits. And then finally, we showed why, if it was a one-shot deal or in the short run, that they would not probably be able to successfully collude because each firm would have incentive to cheat on the agreement. In this video, we'll talk about what would happen if the quantity choice was not sequential. And then we'll move on to talking about what happens if we got into price competition. So first, we know that it might not be true in reality that companies are just picking a quantity at exactly the same time as the others, right? There might be some sort of like observing or entering the market based on what we call a leader in the market. So suppose that we had these same two companies, right? Let's just remind ourselves of the two profit functions again. But let's assume now that company A selects its quantity first, then company B observes this quantity and chooses their own quantity. So you might consider this like a leader in the market, right? They release a product and then another company comes in and chooses how much to sell of a similar product to compete in that market. Example of this might be, I don't know, Apple sometimes might be a good example of a quantity leader. I don't know if they were the first to do like the AirPods, but those kind of caught on. And then you see other companies enter and start producing AirPods, maybe based on kind of like the model and the quantity and pricing decision of the leader firm. Right, so we're starting to get into kind of modeling that behavior in companies. Right, so we have our best response functions, right? Here's our profit for firm A. Suppose that firm A is going first and firm A still knows market demand and they still know what the costs are for each company so that they can just plug in their expectation of what QB will be into the profit function. All right, so again, here's profit function for company A. Company A moving first knows that they can expect that if B is maximizing their profit, they will choose their best response, which was what right here, 500 minus 1/2 QA. Again, we derive this in the same way as before. They have the same demand, same costs as before, so we would get the same best response function. Right, nothing's changed here except the ordering. Firm A is going first, and they know what they expect firm B to produce. So firm A can actually plug in quantity B, or their best response function, into the profit function. And as long as you get this step right in the algebra, it's actually a relatively simple problem, I think, or maybe fewer steps than the Cournot problem had. So let's see it. All right, we've got our profit function here for company A, the first mover, and they know what firm B is going to do. They don't know the exact quantity, but they know that firm B's quantity is going to depend on what A produces or what they produce, right? So they can plug in firm B's best response. Now we're just going to algebra some things out. So I have shown the steps here on minus 500 QA, and then we've got a negative times a negative. That's where this is coming from. And then combined it all together here. So we've got the 500 QA, combine these two, minus 1/2 QA squared. All right, so here's our profit function. What are we going to do? We're going to take the derivative with respect to QA, which now notice, unlike the Cournot problem, does not depend on firm B. The firm A can basically force firm B into a quantity choice. Firm A is just going to maximize their own profit essentially here. So firm A has this profit function. Take the derivative, set equal to 0. So we get a 500 QA to the 0 power. So just 500. Then we got 2 times -1/2, so -1 QA. Right, set that equal to 0. We see QA equals 500. Right, firm B moves second. We know what their best response is, 500 minus 1/2 QA. 500 minus 1/2 of 500 gives us firm B's quantity choice. Now we can find the market price. We can find A's profit, and we can find B's profit. Right, so what we see here is called a first mover advantage. Company A, if they're moving first, if they're the market leader, so to speak, can force B into a particular quantity choice by choosing their own quantity choice and knowing that B will respond based on this best response function. Right, so again, we see that if a company can afford to withstand reduced profits in the short run, what it could actually do is choose a much higher quantity than this, forcing, we can see that if A chose a quantity of, say, 1,000, B would choose 500 minus half of 1,000 equals 0. So firm A could actually attempt to, if it is able to withstand some reduced or negative profits, increase its quantity choice way above the actual profit maximizing choice and try to force B out of the market. Right here, they don't do that. They just choose according to profit maximization. And we see that A makes more profit than B, which is a first mover advantage. And again, we can kind of correlate to this to the real world, the incentive to innovate and be the first company producing a successful product in the market. Right? In the long run, you might be overtaken by competitors, but if you're the first one to be producing AirPods, AirBud is something different. If you're the first one to be producing AirPods, then you've got this first mover advantage. You might make more profit than your competitors. All right, now we're going to talk about what happens if instead the companies compete over prices. In all of these previous oligopoly examples, we're using MC equals MR to find a quantity choice. Either they're doing it at the same time, or here in what we call the Stackelberg or sequential competition, one moves and then the other observes that quantity choice and picks. So here it's possible that actually instead of competing in quantities, we don't maybe observe the other company's quantity exactly, but we can see what price they're charging. Right? You can go out to the store and look at the shelf and see what your competitor's price is, or in the gas station example, they're advertising their prices right there on their sign on the street. So what if our oligopolists can observe each other's prices and then they get to respond? So I'll come back to sort of a mathematical example, but in general, just we're going to approach this mostly theoretically, this particular Bertrand or price competition. But what's going to happen if we start undercutting each other? So each oligopolist, the two gas stations on opposite corners, can observe each other's prices and respond. So let's suppose each gas station has chosen a price of $3. And then all of a sudden one day, one of the gas stations lowers its price to say $2.50 a gallon. What would you expect to happen? If the other oligopolist doesn't also lower its price, if the other gas station doesn't lower its price too, then most people are going to go to the cheaper gas station. So if we have a price competition, if one firm starts undercutting the other firm, this process is going to continue. Right? Once they're both at $2.50, then one firm has the incentive to go a little bit lower than that to try to capture the entire market. So if we get into this price competition, in theory, what will happen is the two companies will just continue undercutting each other's prices until they're all the way down to marginal cost and making zero profit. Right. So for this reason, firms in general, oligopolists would really like to avoid price competition. They engage in other types of competition like advertising and product differentiation, but for the most part, they do not want a price war. Again, the gas stations at the corners, opposite corner, if they kept trying to undercut each other's prices, would eventually make zero profit because their prices would be equal to marginal cost. Right, so that's basically what I'm showing here with a mathematical example. Suppose we have this market demand and their total cost is equal to 1.25 Q, so that marginal cost is 1.25. The market demand, what have I done here? Okay, I think I need to actually update this example problem. But what's happening here is basically we have some sort of consumer's max willingness to pay here, and it should be given by slope intercept form. So it's actually 2.5. Right, the maximum consumers will pay in this market is 2.5. What's the price when quantity is 0? 2.5. So ignore this line for just a second. Maximum willingness to pay in the market is 2.5. Suppose we have these oligopolists with the marginal cost of 1.25. All right, so let's just start with a price of 2.5. If they each charge 2.5, one of the oligopolists has a incentive to undercut. All right, eventually they will get into this price competition all the way down to their marginal cost of $1.25, where they're making zero profit. So again, don't worry as much about the numeric example. This Bertrand price competition is not so much a numeric solving problem. It's more of a conceptual idea that if the oligopolists get into a price competition, their price will be zero. So the oligopolists have incentive to avoid price competition. Right, there's a couple ways that this can happen. One common way that oligopolists avoid price competition is what we call price leadership. So if there's one main firm or one or two main companies in the market, like say Apple, they're able to set a price that basically defines the market price, and the competitors will come in and set prices which are somewhat comparable. Right, Apple and their competition, the product is differentiable or distinguishable. So that kind of complicates a little bit. Maybe the competitors have to charge a slightly lower price. But if there's some main competition in the market, oftentimes firms will respond to the leader's prices rather than trying to engage in some sort of price war or price competition. Right, so that just leads us to this general definition. In reality, again, it's not likely that these oligopolists are going to compete in a price competition and go down to marginal cost. They're going to engage in some sort of either implicit or explicit price fixing. So if you have implicit price fixing, that's where no formal agreement is made, but the two firms kind of settle on some sort of price, which is above marginal cost. Again, you'll see gas stations doing this. Right, they post their prices on the corners, and usually they're pretty much the same. I think in general they haven't actually, made a contract or a formal agreement about that. This is just sort of like an unspoken agreement that the prices are going to be about the same at the two gas stations. And then in an explicit agreement, a formal agreement is actually made to fix the price, and oftentimes firms might like to make some sort of explicit agreement to fix the price to, say, the monopoly price. Generally speaking, these agreements are not legal, but they're difficult to identify and enforce. Okay, so this last bit on the Bertrand competition, again, price competition, this is sort of more of a conceptual idea. Most of the math is coming up here in the Cournot quantity and Stackelberg quantity competitions.